Alright guys, so we're going to go over the June 2022 Edexcel Higher Maths Paper 2. This is question 22 in the paper, the last question of the exam. Again, last question tend to have the highest marks in the paper, and tend to be the most difficult ones, so we'll just go over it as part of revision. So the question says, find algebraically the set of values of x for which x squared minus 49 is greater than 0, 5x squared minus 31x minus 72 is greater than 0. So immediately looking at this question, we're looking at it's testing inequalities, it's testing quadratics, and it wants an answer, the set of values. So that might mean x is greater than s is less than something, x is greater than something, or both of them. So that's what we're looking at here. So the way to answer this question is given us two different equations here. Let's just break it down one by one. So we got to find a solution to this inequality and a solution to this inequality. And once you find the two solutions, just join them all together. So we'll start with this equation here. X squared minus 49 is greater than 0. So we're solving for x, right? Initially, when you look at this, there are different ways to solve this, but the easiest ways is to sort of spot that it's a difference of two squares. And the trick to spotting it's a difference of two squares or dots is basically if you don't have any x terms, there's none of those, and also if this number, the number without any x terms, the coefficient, is a square number. So forget the minus sign for now. Obviously 49 is 7 squared. So if you know that, and if you see that in any equation, it's a difference of two squares. So square number for coefficient and no x terms. So we know the difference of two squares, we can do x minus 7, x plus 7 is greater than 0. Now, the solutions we have is x is greater or less than 0. X is greater or less than 7. X is greater or less than minus 7. Now we don't know which one's which, whether it's greater or less than. To avoid any confusion with signs and stuff, I just think it's easier just to treat it as a normal quadratic. So this might be, make sort of your thinking about it a bit more easier. So just solving a normal quadratic, x is equal to 7, x is equal to minus 7. But that's not what we're doing here, but just for illustration's sake. So that's if you want to just solve the equation, but we're treating it as an inequality. So we have these solutions 7 and minus 7. We don't know which one's which. So there's different ways to find out what the range of values to solve this is. Basically, one way could be trying to sub it in. So for example, if you say if x is equal to 8, then what does that mean? That means that 8 squared minus 49 is equal to 64 minus 49. It is a calculator paper, so just get your calculator out. It's 15, which is greater than 0. That's correct. That fits this inequality, the original inequality. So x is a solution there. So we could say x is greater than 7 as one solution. Now what about x minus 7? Well, if you have no knowledge of how quadratic looks like, then you could do the subbing in technique again, but basically it would be x is less than minus 7, but we could check that. For example, x is equal to minus 8. It means minus 8 squared minus 49 is equal to 15 again. It's greater than 0. That's correct. So the other solution is x is less than minus 7. The other way to spot this is essentially to use your knowledge of quadratic equations. If the coefficient of x is positive, i.e. it's not minus x, then the quadratic would look, you know, something like this. Sorry, bear with me. All right. This would be minus 49. Okay, because when x is 0, the y is minus 49. So that's what it would look like. But if the equation was instead minus x squared minus 49, then essentially what you're looking at is it'll be up here. Sorry, it'll be like this. And in which case it doesn't intersect any of the y values. But essentially we've got a graph looking like this. Okay, and we found the solutions. Minus 7, just label y and x axes. Okay, so it's looking for everything for which y is greater than minus 49. X squared minus 49 is greater than 0. So we are looking at all of these values and all of these values, and those values of y are greater than 0 is when x is greater than 7. So x is greater than 7. X is less than minus 7. That's when y is above 0. So that's our solutions there. X greater than 7, x less than minus 7. Hope that makes sense. Let me know if it doesn't. But basically, it just assumes your knowledge about quadratic graphs, quadratic equations. Okay. When in doubt, just sub in a bunch of random numbers, and you should be able to plot the different parts of the graph. For example, if you're unsure about anything, just say if x equals 1, then what's the y? Well, we're just taking our y is equal to x squared minus 49. If x equals 1, y is equal to 1 minus 49. Y is equal to minus 48. If x equals 2, what's y? Y would be equal to 2 squared minus 49. That's 4 minus 49. Y is equal to minus 45, etc., etc. And you can just plot it here. So x is 1, x is 2. And you'll basically see that the curve looks like this. So essentially, all values of x that solve this formula is x greater than 7, x minus 7. Another way to do this is to basically see, I'm just putting a little space here, x squared minus 49 is greater than 0. We want the values of x for which this equation is true. So if you rearrange the formula, x squared is greater than 49. We want the values of x which are greater than 49. So if you sub in minus 7 squared, that equals 49. 7 squared, that equals 49. Anything less than minus 7, i.e. minus 8 squared, that's equal to 64, which is greater than 49. It satisfies that condition. If we do 9, which is greater than 7 squared, is equal to 81. Again, satisfying that formula. So again, all values of, and you can see the smaller x is from minus 7 or the greater x is from 7, this equation will be satisfied, will always be satisfied. And that's the equation that we're bound to in this question. Okay. The next part of the question is looking at 5x squared minus 31x minus 72 is greater than 0. So we want basically to find x such that 5x squared minus 31x minus 72 is greater than 0. Okay. Again, just to make it clear exactly what we're doing, we want to answer the question, what values of x satisfy or make true this equation? If you plug in x equals 1, will this whole thing be greater than 0? That's what we're trying to find out. What are the values of x that make this equation true? Okay. And again, the way to solve this is, I'd say forget that it's an inequalities. Treat it as a normal quadratic Okay, we need to solve this. The easiest way is a calculator paper is use the quadratic formula. So, you know, quadratic formula, you have to memorize this one, would be minus b plus or minus the square root b squared minus 4ac all over 2a, where a, b, and c are ax squared plus bx plus c is equal to 0. In our case, a is equal to 5, b is equal to minus 31, c is equal to minus 72. Okay, so just plug that into the calculator. So what you'll put into your calculator is minus 31 plus, and then you do minus afterwards, plus or minus 31 squared minus 4 times 5 minus 72 all over 2 is 5. So plugging that into the calculator just really quickly, it's 31. Let's do plus first. Square root of that's 31 squared minus 4 times 5 times minus 72. 2 times 5. Okay, you get 8. So for the plus value, you get x is equal to 8. And then if you do the minus 31 minus the square root of b squared minus 4ac, you get x is equal to minus 1.8. Now, we want a range of values because you've got to remember it's actually an inequality. So what values of x satisfy it? Okay, so again, we know that the quadratic formula is going to look, the quadratic equation on a graph is going to look something like this. And now we know from solving the quadratic formula that actually it will look like this. So we know that when x equals 8 and x equals minus 1.8, y is equal to 0. So that's y, that's x, 0. So it intersects at minus 1.8 and then at 8. Okay, so the graph will look something like this. Okay, and this point is the point at which x equals 0, and that was equal to minus 72. We don't need to calculate that, but you'll know that because if you sub in 0 into here, you get 5 times 0 squared minus 31 times 0 minus 72 is equals 0. We're doing equals because we're trying to find where it cuts the y-axis, and basically that cancels out, and you'll see it, is equal to y, and then you'll see that y is equal to minus 72. Okay, let me know if you have any questions on that. Just leave a comment in the comment section. Okay, so that's what the graph looks like. So again, we want to find the values of x for which y is greater than 0. Why? So the question is, why is it that we're trying to find the values of x for which y is greater than 0? Well, because if you treat this whole thing as equal to y, then that means y is equal to 5x squared minus 31x minus 72. That's what y is. And if that's equal to y, then this equation, this whole thing, is just y is greater than 0. Because y is equal to 5x minus 31 squared minus 31x minus 72. So we're trying to find everything for which y is above 0. So this is the point that y is equal to 0 at the center there. Well, I mean, that's not where the graph would be, but yeah, that's y is 0. Everything for which y is greater than 0 is is here on the graph and here on the graph. Okay, so basically the values of x for which y is greater than 0 is x is greater than 8 and x is less than minus 1.8. Again, just using the same explanation here. Okay, just to sort of help with explaining it. This is the graph. Here in this case, y is equal to x squared minus 49. And this was our original equation. If y is equal to x squared minus 49, then and x squared minus 49 is greater than 0, then that means y is greater than 0. So that's our inequality. That's the conditions for which we're bound. And basically y is greater than 0, i.e. anything above this line, y is greater than 0 at these points in the graph. Over here and over here. That's where y is greater than 0. And at those points, x is greater than 7 and x is less than minus 7. Okay, so to summarize, when x is greater than 7, y is greater than 0. And when y is greater than 0, x squared minus 49 is greater than 0. So that satisfies the equation. Also, x is greater than 7 here. And when x is less than minus 7, i.e. this area, this is x is greater than 7, this is x is less than minus 7, y is greater than 0. And what is y? Y is x squared minus 49. It's that bit there. X squared minus 49 is greater than 0. So when x is greater than 7, this is satisfied. When x is less than minus 7, this is satisfied. Okay. Similarly, if we take y to be 5x squared minus 31x minus 72, the solutions to this at 0 is 8 and minus 1.8. We found that with the quadratic formula. Now, y is greater than 0, i.e. everything above the x-axis is where y is greater than 0. So all of this, all of that, and all of this onwards to infinity, all of that is y greater than 0. And y is greater than 0 when x is greater than 8, and y is greater than 0 when x is less than minus 1.8. Hence our solution to the inequality. Again, rephrasing, when x is less than minus 1.8, 5x squared minus 31x minus 72 is greater than 0, so that's satisfied. When x is greater than 8, 5x squared minus 31x minus 72 is greater than 0 again. Sorry, these two are the same formulas. So that's what we've done. Now we haven't answered the question. The question says the set of values of x for which this is satisfied and this is satisfied. So basically what we found in the first equation, we have found that for x squared minus 49 to be greater than 0, this means x must be greater than 7 and x must be less than minus 7. Okay, those are our solutions here. Those are our answers. And for 5x squared, what is it? Minus 31x minus 72 to be greater than 0, we require x to be greater than 8 and x to be less than minus 1.8. Okay, so we need a condition that satisfied this and this. These two need to be true. So let's just take a normal line graph here. Okay, this is number 7, this is number 8, this is minus 1.8, this is minus 7. So our inequality says x is greater than 7. But I'll do it different colors. X is greater than 7 and x is less than 7. Okay, over here we're saying x is greater than 8 x is less than minus 1.8. Okay, which set of values of x exists such that both the green and the blue are true? So let's take the negative side. the green and the blue are only true here when x is less than minus 7. So from this bit onwards. Because if x is, for example, less than minus 5, then it's not less than minus 7, if that makes sense. It needs to satisfy both x is less than minus 7 and x is less than minus 1.8. Now here, x is greater than 7 and x is greater than 8. Well, x can't be greater than 7 and 8 at the same time, but it can be greater than 7 if it's only greater than 8, if that makes sense. So that's the set of values of x that we need here. So the final answer is x is less than minus 7 and x is greater than 8. Again, rephrasing. If this is true, then x satisfies this and this at the same time. We can show you again on a graph how it would look like. It might be a bit busy, a bit messier, but I hope you get the gist from here. But just to nail it down back. Okay, you've got a y-axis, x-axis. Okay, so the original graph cuts at minus 7, 7, and minus 49. Okay, minus 49, minus 7, 7. Okay, and the second equation, it cuts at minus 1.88. Okay, and then I believe minus 72. So the second graph looks something like this. Sorry, that was really bad. Something like this. Okay, so that's y is equal to 5x squared minus 31x minus 72. That's y is equal to x squared minus 49. Now, the values of x for which both of those equations is greater than 0. So both of those equations are greater than 0 here. Sorry. Let me just redraw this one. I've got to sort of show it in a way that makes a bit of sense. Let's put minus 1.8 here just for clarity. Okay. The points at which it's greater than 0 is here, 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 and here. But the points at which they're both greater than 0 for the same values of x is basically here. So from this value of x onwards, here in this space, if x is here, then y equals x squared minus 49 is not greater than 0. In this space, if x is here, if x is, for example, 7.5, then y is equal to 5x squared minus 31x minus 72 is not greater than 0. So basically, the only values of x that work is these values of x, everything onwards, and these values of x, everything onwards. So, I hope that makes sense. All of these values of x and all of these values of x satisfy both of these equations being greater than 0 at the same time. Hope this helps to answer the last question, question 22. There's lots of different ways to do this question. You could complete the square to find the solutions. You could use a factorization method to factorize this. But you know, if you want me to go over this, let me know. But yep, any questions as well, just let me know. Thank you.